Hi, everybody. Welcome. September 3rd today. Let's go ahead and jump into our second question into the chat. When is your B day? Is the check-in question. Go into the chat so we could all take a see when's everyone's B day. Oh, we got it today. Happy birthday, Marjorie. Woohoo! Happy birthday. Wait, there's more today. Bianca too. Happy birthday. So Marjorie and Bianca, happy birthday. Wow. I did not know your birthdays were today. Cool, we got a lot of Junes. Ooh, some Decembers, November, Marches. Yeah, happy birthday, y'all. We had one that just passed, July 13. We got some Marches. Yes, happy birthday, y'all. Cool, and we got some February. Let me just let in a few more admits. Welcome, everybody. We're doing the just joined us. We're doing the quick check-in question, which is put your B day in the chat. We got 2 birthdays in here today. Happy birthday. Awesome. We got some August ones recently. Gained some. Awesome, awesome. And then, oh yeah, let me let in Marvin. Yeah, mine. Let me go ahead and put mine in there. Mine is October 29. I don't know if we have any other October babies. I know there's December. I guess I'm the only October? Okay. Cool. Thank you, everybody, for sharing that. And happy birthday to Marjorie. And who was the second one? It was Marjorie and Bianca. So happy birthday to you two. All right, cool. Let's go ahead and move on. Yep, and thank you for sharing, Marvin. Got it. Looks like I'm the only October. I'm a Scorpio. Maybe I should ask that next time. What's your sign? Okay, let's move on. All right, cool. So our agenda today, we had a quick check-in. We had some few birthdays, awesome. So we finished up, or we're kind of moving on a little bit from composition of functions. I know we're deeply working into that. We will revisit it though, so don't feel like we're ending it, books closed, because we're not. We're going to revisit it next week. I plan to have you re-engage with compositions by looking at each other's work and trying to like correct errors and things like that. So don't worry about that. We will continue to work on compositions. But today we will be learning something new, something called inverse functions. Maybe you've heard of it, maybe you haven't. I do not know because I don't know. Y'all had a new curriculum last year, so I'm not exactly sure what Algebra 2 covered. But again, I'm going to treat it as if we never learned what it was and we're learning it fresh today. So we're going to first have the introduction of what an inverse function is with Desmos. After that, we're going to take formal notes. So kind of like the Desmos as an investigation. Then we'll take formal notes. We'll hopefully get into that checkout question. As a reminder, we do have asynchronous number 6. It's due today at midnight. Again, the expectation is try your best, try to show your steps. All of that is super important because again, we're going to be looking at some of the work that you all produce next week. And by the way, y'all, next week is going to be the last week of the module. So just keep that in mind because then after that, y'all will switch classes. You won't see me for 3 weeks after. So just as a reminder, make sure that you're catching up on any work that you missed. And I'm happy to work with you on that. Okay. So let's jump into the Desmos here. So we are period 1. So you want to go ahead and go to student.desmos.com and go ahead and type in this code. Is this the one with the negative y and x or something like that? Maybe. I mean, it's the one about switching x and y. Maybe y'all recall something like that. But if y'all had some prior knowledge to this, I mean, that would make it nicer, but if not, it's okay. I mean, something does happen with x and y, and I'm just reading the chat there from Jeanette's comment. All right, go ahead and get logged in, everyone, and then I'm gonna, and by the way, who I don't have right now is Miles, August, Latravion, Marco, and that's it. So just double checking that's who I don't have here, so I could go ahead and mark the attendance. And give me a sec as I try to text and remind those people who are not here. Again, if you're friends with any of them, try and text them. Okay, so let me go ahead and jump into the Desmos. I hope you all got the code so I can see who's in now. I'm gonna have to, oops, nope. Go to Desmos first. Later we'll be doing some notes, but right now it's Desmos. All right, we got 21 of us that are in. We have 24 participants, so we're just waiting on 3 more to get logged in. Again, here's the code. Also, when I X this, the code shows up right here in the upper left-hand side. So for this one, I am gonna soon kind of restrict our screens. I know a lot of you are kind of exploring all the screens there. But just make sure you get logged in and make sure that as we're doing this activity that you're completing it along as we go. So as long as it go, it's like, please don't stay on a slide that we're not on and so forth. And you wanna make sure you complete this as well for credit. So some of the Desmos I am entering in some credit for, and this one's one that I'm interested in assigning credit for. So let me go ahead and hit the pacing. And I'm going to first move us here. Sorry, y'all, I'm restricting everyone to screen 1. I hope you're there. Yeah, restricting the screen 1. Cool, we have 22 of us logged in. Again, make sure this is for credit. I'll leave it up to you, but this is the standards that we're gonna cover. Finding inverse functions, solve an equation for a simple function. We'll be doing that in our notes. We're not gonna be solving in this Desmos. And in our notes, we're going to be able to write the inverse of a function by interchanging the x values solving for y. So that's kind of like what this is encompassing. And again, if you just joined us right now, we're on student.desmos.com. And then you're going to input the code that's right here where my mouse is at. So student.desmos.com, the code is up here. All right, let's go ahead and move us on to this next slide. So in a second, we're going to be graphing these coordinates on the next slide. So in the chat, go ahead and put down, what do you notice about these 2 coordinates that we're going to, these 2 sets of coordinates that we're going to graph. So this is the first set that we're going to graph, and this is the second set. So right now we're just exploring, what do you notice about these 2 sets? Does anyone have a pencil? LOL. Anyways, go into the chat and let's write down, what do we notice? They have the same numbers. Yes, they do. They both have the same numbers. Yes, that is correct. And then Jose added, but they're switched. The X and Y are flipped for 1 and 2. The X and Y is reversed. I noticed that the second quadrants are flipped. They're the same number but placed differently in the X and Y. You are all correct. So these two sets of coordinates are inverses. So what an inverse is the X and Y coordinates swap positions, just like you see right here. So for example, 0, 6 becomes 6, 0. This became 3, -1, so forth. So that's what we're going to be graphing now in a second. So everyone's going to have a chance, because once we graph it, we're going to notice something about these two sets that are inverses of each other. There's going to be like a property that we're going to see. So let's go to the next one. Oh, for this one, I need you to actually have access. So hold on, like that. I need you to have access to the coordinates that you're graphing and the graph itself. Okay, someone already did their graph. Cool. For those of you who need some assistance in doing the graph, I'll do it right here, but some of us already got that down. Let me go ahead and show you how to graph your points if you don't know how. So basically here, the first point that I want to graph is up here, 0, 6. I'm just going to put 0, 6. And then you don't see it, but if you scroll out, you'll see the point right there. Then you do your next point. And the next point, if you look back into the previous slide, is -1, 3. And then there's your next point, and so forth. So you should have 6 overall graphed points. Let me know if anyone needs me to again show you how I'm doing the points on these graph. And again, you're using the points from slide 2. All right, so good. A few of us are getting that down. And if you're struggling and if you want to verify your work, you could check out the work that we're doing here on the screens. Again, you want to make sure that you are participating for your credit. Do make sure that we see that you're following along so I could help or jump in if you're stuck. Let me also anonymize this so I could just give some pointers. So right now when I anonymize this, just pay attention to what your name is, because I want to notice what's happening in some of these graphs. Let's see. Like this one here, I notice it's like bunched up. Okay, no, this is the same thing. It's just zoomed out. Okay, Kathleen, you got it good. So this graph right here looks different from everyone else's because this particular student has it like zoomed out a lot, but it's the same. And these ones are more zoomed in. Cool. Let's make sure everybody there gets their points down in their graph, because I want us all to investigate what's happening when you're graphing a set of points and the inverse points. So James, Katie, and Martin, please make sure you, and Albert and Neil, if you guys can try to get started on some graphs, great. I see James is starting there. I want to make sure that we're all following along and we all understand how to put in these points. Okay, cool. So we're getting there. So let me use, let's see, I'm going to use Dana, this example right here, this exemplar. So we all have, or we should get points that look something like this. So in the chat, I want you to put, what do you notice? So here, first off, let me just circle it. So this right here is the original set. And then these points right here are the inverse set. So inverse, that's the points that got reversed. So in the chat, I'd like us to put, what do you notice about the two sets of points? Like, what are they doing? We got some stuff in the chat. Same shape, but went down. So the shape looks similar, but the set got moved down or something. Jose Juarez says it's a V. So it does sort of look like a V, right? If we like connected all the points. Maria says they're increasing. Yeah, they both look like they're increasing. Miles says mirror. I like the word that you use, Miles. So you notice that these are kind of like mirroring each other. I like that. Ariana notices that they're linear. Good. Awesome. So I'm going to go ahead and put together what the feedback we got so far. So I agree, it looks like a V. It does look like these are translated or moved down a bit. So what's actually happening here, let me go ahead and tell you, these are a mirror image of each other. And it does look like a V because they are a mirror image. So I like the word that you brought in there, Miles. Basically, they are a mirror, but they're a mirror along a specific line. We're going to have time to write these in our notes later, but for now you could just watch. So the specific line, oh, let me get my tool here, that this is a mirror image of is this line right here. Let me just draw it dotted. It's going down, it goes through the origin. Yes, Miles is a goat. Greatest of all time. So what these points are is that they're a mirror image across or along this line. It's like, think of this line as the mirror, right? So it's like I look in the mirror and it's reflecting across there. Mirror reflecting there, mirror there. So this mirror line right here has a specific name. It's the name of y, or it's the function of y equals x. So basically, when you graph inverse with its original function, what you get is a reflection across the line y equals x. Basically, the reflection is the mirror image across the line y equals x. So that's actually what's happening here. And that's why it sort of looked like a V, because they're a mirror image. So this is like a fact about inverse functions that we're gonna have down. So I'm going to go ahead and erase this because I know we're not copying this down right now, but this is just an investigation. Let me clear my drawings. So again, just make sure that you do got your points graphed down and you're following along with us. Again, we're not writing anything down right now. Cool, great. So we're almost all there, and then like Neil over here, just make sure you get some points down as we go along. So next slide. So here we go. What is an inverse function? And again, we're going to have time to write this down in a bit. The inverse of a function basically undoes the function rule. What that means is, let's say you have a function x plus 1. The inverse of x plus 1 would be x minus 1. It does the opposite, actually. So the inverse function undoes a function rule. In my head, I think of it as doing the opposite. So if you have a set of ordered pairs, like the ones we just had, basically you just switch or reverse the x and the y coordinates. In other words, the domain and range, they're switching. The graph of the inverse function is a reflection of the function graph over the line y equals x. That's what we saw right now. So that's just some learnings that we're getting down. Cool. Let me go ahead and move on to this visual right here. This is right here. So on slide number 5, let's go ahead and move on to slide number 5. This is just like a visual picture for visual learners to check out what is a function and what is its inverse. Again, I have this screenshot for our notes, so don't worry, we will take notes on these. We will get these down, but for now we're just talking. So for example, like for a regular function f right here, if you plug in a number for x, you get an output. And for here, it's kind of like depicted as x is apple and y is lemons. So if you put in apples, you get lemons. But if you have an inverse function, if you put lemons, you get back apples. That's what the inverse function is going to do. It's kind of like you have an output, you plug it in, you get the input back. So it's going to be funny like that. But it's going to be very straightforward, you'll see. But basically, if you notice down here, if you have a function, a set of coordinate points like here, all you have swap them and you have your answer. So if I was to ask you a quiz question, like, hey, here's a coordinate point, what's the inverse? You just got to switch the x and y coordinates. So right now we don't have to write this down. Right now it's just talking. We will be writing down when it's notes time. So right now, let's just look at it. You can if you want to, though. I won't restrict you on that. Okay, next up, some notation. Again, we're gonna talk, so this is slide number 6, y'all. Slide number 6. So when we write our notes, I will be talking about this new notation. So this is the inverse notation. It's F, and it looks like a power -1, parentheses, X, close parentheses. This notation basically tells us it's the inverse of a function. And then here's a note that it does not mean you do this to the -1 power. Nope. This just means inverse. It doesn't mean that we're going to do anything like this. And again, we don't have to write this down right now, everybody. And make sure for those of us who are still in the graph, let's move on to the other parts unless you're just watching me on the screen. So that's okay. Next part, just so that we have some exposure. Here are the different methods for finding the inverse of a function. So again, what we've been talking about is just the switching the x and the y. And the other one is if you have a graph, all you have to do is like reflect it across the line y equals x and you have your inverse. The last one we're going to talk about when we hit our notes is all you have to do is interchange y and x and then you're going to solve for y. So we're going to be doing some algebra later in our notes. So this is just a preview of what we're going to write down and see later. Again, you don't have to write this down yet. This is just for you to see. Okay. Let's go ahead and try to put this all together with some more exploration. Let's all move to slide number 8. And next. There we go. Let's all move to slide number 8, please. All right, so what I'd like you to do is here you have a table, X, Y, and they'd like you to please draw the inverse of this table. So we talked about what you do when you have an inverse function. Go ahead and try to fill that out. Remember, when you graph your points, you should be seeing a reflection or a mirror image across the line y equals x. Go ahead and take some time to do that.
It's done. I got a question.
Yes.
All right. So basically, for that graphing thing, is it basically like what we did the first time, just kind of like switching it?
That's correct.
Kinda? Oh, okay.
Yes, that's perfectly correct. Yes. And then for this one, you just want to make sure you graph it correctly. And then when you look visually in your graph, you should see that it's like the mirror image thing happening.
All right. Thank you.
Welcome. All right, I'm already taking a look at everyone's little graphs. I'm seeing good mirror images happening. I like that for this one, you could see the original function's a different color from the inverse function. Okay, so everyone right now on this screen is participating. Awesome. Okay, well, let's see. What are we confused about? Go ahead and you could either unmute yourself or you could write it in the chat. And I'm happy to like kind of guide some of us through it. I could pretend to be a student to help guide us through. Oh yeah, so currently we're all restricted to slide 8, by the way. I'm pausing on slide 8 so that we can all try this. And Ariana, I got your question about I'm kind of confused. Let me know what you're confused about, but let me just try to walk you through this. What you have here is an original function. It's graphed in green here, these green points. And what we're trying to do in this slide is we're trying to graph the inverse of this function. What you have to do to find the inverse is all you got to do, what we've been talking about, is you switch x and y. So basically, take a look here. My x is -2, my y is 3. What you're going to do is you're going to swap that. Now I'm going to make x 3 and my y -2. So see, notice how this red point that I just did, that's the inverse of this original point. Notice how they're like a mirror image from each other on the line y equals x. So that's what we're doing, and you're going to continue to fill out this second table by drawing the inverses of these. Okay. Cool. So then you want to just make sure you verify, right, that they are inverses and they look like inverses of each other. So for example, like let me click on Herman whale. So notice that for this one, I could see that every single point is a reflection of each itself. So if I draw the line y equals x that goes straight through the origin right here. So this is the line y equals x. The point should be a mirror image from this line.
That's kind of a cool method.
Yeah, it's interesting, right? So this is really good for like visual learners. Oh no, my computer's about to die. Hold on. But notice how you could like verify your work because these points need to be a reflection. So you're just looking at that and you're seeing that like, okay, they are reflecting across the line y equals x. And this line just always goes through the origin. Let me charge my thing. Okay. Cool. So go ahead and complete your graphs. And again, you want to verify that they are indeed a mirror image, because if they're not, and you know you did something wrong or you graphed a point incorrectly. So let's go ahead and let me clear that, and I'm going to move us on. And by the way, we're not going to complete this whole activity, just parts of it. Awesome. So I'm seeing some mirror images there. I'm seeing something interesting here for this one. So I'm interested in how this one is. So this one I think has a bit of errors. And the reason I think for this one, so I don't know who the student is, but I'm going to try to give you feedback. So the goal is you just want to switch these two, the positions. But I noticed that for this one, you made it negative. So don't make it negative. Otherwise, you're not getting that reflection. You just got to switch the points. So this should be positive. And likewise, some of them it's like you switched it, but then you change the sign. Don't do that because that's not your inverse. You just keep the same sign and switch, that's all. So that's feedback for this student. All right, y'all, let's go on.
I have a question.
Oh yes, go ahead.
Wait, can I show you like through the screen?
I wonder, oh wait, which one are you?
I don't know, because I have this right here, but the table is right. I don't know.
What's your name?
Jenny.
Jeanette.
Oh, George Burkhoff.
George Burkhoff. Your graph looks perfect.
But that oh, never mind.
Yeah, I think the other one was like more zoomed in or something. Yours looks.
Yes, I was gonna say that probably has something to do with zooming.
I think the other graph just had the scale different, but yours is great.
Thank you.
All right, y'all, let's move on to the next one. So finding the inverse of this now. Now you have a line there. So when you go ahead and fill in your points here, because this little squiggles here, this is the line. So it's going to give you a line now. So I want you all to see what happens if you try to graph the inverse of this line. Go ahead and take your time to fill in the table. All right. For those of us who are right now filling in their table, I'm noticing like a trend in these graphs. You kind of notice like it's an X, like a sideways slanted X happening. Let me click on Arthur. So notice that this is also indeed going to be a reflection across the line y equals x, because again, if you draw your little like dotted line thingy, it's going to go through right the middle where they cross. Even though it's my thing is crooked, but it should go directly through it. So you notice that it's still a mirror image across the line y equals x. So it's like the purple line looking at itself in the mirror. So this purple part goes this way. This purple part goes that way. So we still get that mirror image happening, even when it's a line. So again, that's what makes an inverse function. When you graph it, you get this specific property that it's a mirror image across this line. It's a very special property. Let me go ahead and, cool. So let's go ahead and do one more practice run to see this in action. I think we'll stop at slide 10. So go ahead and take a look at slide 10. So for this one here, first off, let's take out this. So notice how you have this purple line in there. We could take it off. Basically what you're trying to find is the inverse of this. And this right here is not a function, notice. And it's not a function because it fails the, vertical line test. It would cross it more than once. So this is not a function, but that does not mean you cannot find the inverse of it. You can still find the inverse. It's just going to be called an inverse relation, and that's fine. It won't be called an inverse function, though. So go ahead and try to draw the inverse of this green thing. And again, if it helps, you could remove this purple thing, which is the line y equals x. I think they put this here so you could see that it's going to be a reflection. Ooh, this one looks interesting and cool. This one you could really see that mirror image happening. I like it. It looks like, I don't know. It looks cool, like a plane. Great, so we have 22 of us there on the screen. Make sure that if you're not with us there drawing your inverse graph, that you draw it. So yeah, as you notice, again, across the line y equals x, you're going to get that mirror image, and you can make really cool stuff by using that kind of symmetry happening there. Amazing. All right. So again, if you're following along, please make sure that you finish it up to slide 10, because that's where we're going to pause. So I'm going to go ahead and like open it up all. So wait, no. Oh yeah, I have to just click stop pasting. There we go. So now you should be able to see all previous slides. You could even see the after slides, but we're actually not going to be doing these after slides because I'm going to just hit us into notes so we can actually talk about how to find an inverse function. So you don't have to do after 10. Our only goal is to do up to 10. So let's go ahead and move on from that activity. Again, if you're just lost or you still need more time to finish up to 10, please make sure you do so. Let's go ahead and hit pause on that activity. And what I need us to do is transition into notes. So please make sure you got your notes and pencil out, because now we're going to write all this down, all the stuff that we just seen, and we're going to learn how to find the inverse given a function, like an equation, not like a graph or something, but an actual equation. So let's go into our notes. Notebook and pencil out. I'm going to give you some time to get that ready. Okay. All right, let's go. So you're going to title this as, well, first try to put the date in. It is the 3rd, September 3rd. We're going to title this inverse functions, and here's our learning target. I can define an inverse function and create inverse functions. That's going to be our goals. I mean, sure, if you're able to write with a crayon, that's cool. As long as you could read it, Dennis. All right, y'all, let's have a few seconds to write this down. All right, cool. Let's go ahead and move on to the next slide. Cool, so this was actually in the Desmos. You could go ahead and copy this down as a basic example of how to find an inverse if you have coordinate points. So again, on the left side, you have your original function set. Usually that's given to you, or you could even create your own set. Once you have that, to find the inverse, that's the notation up here. And all you got to do is switch the x and y coordinates. So take some time to copy down this to the best that you can. And we have 30 seconds on this slide. So I'm hoping that was enough time for us in this slide. Let me know if anyone needs me to like slow down. I'm currently at 30 seconds per slide. Again, let me know if that's too fast. Let me switch over to the next slide. Okay, so these are some important things you should know about what an inverse function does. I'm going to read through them, and after I read through them, I'll give us 30 seconds to get the gist of it down. Again, you don't have to write this word for word, as long as you just, for each bullet, put the gist of what, you know, in your own words, what you should know. So basically, the inverse of a function undoes the function rule. If you have a set of ordered pairs, you reverse the x and y coordinates. In other words, and then using math language, you're reversing domain and range. They're switching places. The graph of the inverse function is the reflection of the function graph over the line y equals x. So those are things and facts to know about inverse functions. Let's have 30 seconds on this part. All right, hopefully you got like the gist of each bullet point down. Let me go ahead and switch the slide. Unless you in the chat need more time, just let me know. Okay, so this one's super important because it's kind of like the guideline steps. So the methods of finding the inverse. So again, step one, if you have an ordered pair, that's the more straightforward one. All you got to do is interchange or switch the x and y coordinates. Number two, let's say I give you a graph and I'm like, hey, find the inverse. All you got to do is you could reflect the graph yourself across the line y equals x. Or, you know, if you have the graph, you could kind of see the coordinate points on there. You could just reverse the coordinate points and graph those. So those are the strategies for trying to like graph an inverse function for number two. Number three is the one we actually need to go through. That's the algebra part. So this is the one where you have an equation. There's certain steps that we need to do. We would interchange the y into x and we need to solve for y. That's going to be what I'm going to talk about in a second. That's the one that's the algebra portion. So let me go ahead and have 30 seconds on this portion. Okay, cool. Hopefully we got this down. Let's go on to the next portion. How to find the inverse function. So these steps are specific for the ones that I'm going to jump into, which is when you have an equation. So here are the steps when you have an equation. I'm going to go over it. Once I go over the steps, you'll have 30 seconds to get these down. Okay, step one. In order to find the inverse function of an equation, what we'll be doing is we're going to rewrite the f of x as y, because f of x means y. Next, what we'll be doing when we're using an equation to solve for the inverse function is we're going to switch the x and the y. Because remember, we saw that happen when we're graphing. We saw the switch. Step three. What we're going to be doing, though, to solve the inverse equation then is going to be this. We're going to solve the equation from step two for y. So this one you got to see in action to understand it, to be honest. And number four, the last thing when you're finding the inverse function of an equation is you're going to replace the y from step three with the inverse notation f inverse of x. And that's the notation right there. Let me give you all 30 seconds to copy this down, and then we're going to see it in action with an example. All right, y'all, let's jump into the examples. So for this one, I have to move into my PowerPoint because on Google Slides, I can't do the fractions that will come up. So let me just do that switch. So right now we're gonna move into an example problem. Hold on a second. Just need to open up PowerPoint. There we go. Don't be afraid. Let's do this. Okay, here's example one, everybody. So this is the steps to finding the inverse of an actual equation like this. And we're going to be applying those steps that I talked about. Go ahead and copy down example one. Find the inverse of f of x equals 2x plus 3. And we're going to be going through the steps that you all copied down. Step one, rewrite f of x as y. That's step one there. Step two, switch x and y. That's step two. And I'll just pause here to make sure we're writing it down. Step three is where the algebra comes up. So step three says solve the equation for y from step two. So step three right here, let me just underline. We're going to be trying to solve for y. That means we need to get this y by itself. And then once we solve for that y, we'll basically have our inverse function. So we need to get y by itself. So we're going to be using some algebra. In order to get y by itself, you usually start farther out. What I mean by that is this plus 3 is kind of more farther out in the equation. So I'm going to start with getting rid of this 3 because my goal is to get the y by itself. I know there's a 2 in front of it, but first let's take care of the 3. In order to get rid of 3, instead of adding 3, we're going to subtract 3 from both sides of the equal sign, so of the equation. So on this right side, plus 3 and minus 3, that's 0, so that goes away. And on the left-hand side, you're going to have x minus 3 equals 2y. Because notice this minus 3 went over here. Because these two are not like terms, you leave it as x minus 3. Now for this one, I still need to get y by itself. I'm almost done, but it's not necessarily by itself because that 2 is in the way. So I need this y to be free. Then I'll be done. So maybe I'll pose the question into the chat. How do I get rid of the 2? What do I do on both sides? All right, we got some answers. So Jeanette says divide. Juliana specifically says divide by 2. You both are correct. That's what we're going to do next. Because, and the reason why we divide everybody is because this is 2 times y, and the opposite of multiplication is division. So how you usually undo or get rid of something is you do the opposite of it. So we got to divide both sides by 2, and that's what I did here. Except I want to make sure I don't skip the step that I did this. I divided both sides by 2. 2 divided by 2, that cancels out, and that's why the y is left by itself over here. And on this side, the x minus 3, both terms got divided by 2, so you have to write the fraction bar big enough to hold both of them, if that makes sense. They both got divided by 2. So that's why the fraction bar is huge. Okay. Next thing we could do for simplification purposes, we can do this. So if you have a giant fraction bar like that, this is a strategy. You can split the fraction bar and rewrite it like this. But to be honest, I can accept this as the answer too, but this is just, I don't know, it just looks nicer for me. And then we're almost done. So, okay, we solved for y. Step 3 is done. The last and final step when it comes to the inverse function is all you got to do is rewrite that y with inverse notation. So that y that I'm talking to is this one. Once you solve for y, all you got to do now is rewrite with inverse notation, and that's step 4. That's your answer. This right here is your inverse function. That is your answer. So again, let me just reiterate what we did. We tried to find the inverse of this. We had to use 4 steps to get there. What I mean by 4 steps is 4 directions. Step 1, we rewrote f of x as y. Step 2, you switched x and y. Step 3 is you had to solve for y, and that's where the algebra came. Once your y was solved for, all you had to do for step 4 was rewrite that y with the correct notation, which is inverse function. Let me also let you know that if you all go to Desmos, you don't have to do this, but if you go to Desmos and you graph this with this new function here, you're going to see that they're mirror images of each other. They're going to look something like an X because these are lines. You're going to see that they are in fact inverse functions, and that the algebra we did here verifies that fact. So there's a way to check your work as well. Let me just pause here, make sure we get this down, and I'm gonna pause for any questions, if any. If anyone has any clarifying questions about the process.
I have a question.
Yes.
So is the f like, is there always gonna be -1?
Yes. So this
Okay.
right, yeah, this right here is always the inverse notation. This does not mean it doesn't mean to the -1 power. It just means inverse notation. And to be honest, I don't know exactly why they use it. It's just the way they write it. Cool. Thank you for the question. Let me know if anyone else has any additional questions about this or the process. The asynchronous assignment that I'll be posting for tomorrow that's due Sunday will be about inverse functions. So you're going to take a look at a little bit of that as well. Awesome. Okay, so if we don't have any more questions on this, I mean, we did have some more examples, but that's fine. I'm gonna pause here because we only have like 4 minutes. So let me go ahead and clear my drawings as long as we got example 1. By the way, today, I do want you to submit your notes on your inverse functions as well. I need to create that assignment though, so just give me a sec, that will show up. I want you to submit only your inverse function notes that you took today. You don't have to worry about the other ones yet or at all. Escape. We'll continue to talk about more examples, but before that, I'd like you to do a process and reflection on what we learned right now. So in the chat, I'd like you to put List one thing you learned about inverse functions today, or list a question that you still have about inverse functions. Go ahead and put that into the chat as you reflect. Good, good. We got some reflections starting up there. Good. Awesome. We're seeing a lot of the vocabulary coming up. I see reflection, interchanging, mirrors, ooh, domain and range. So we're getting some precise math vocabulary coming up here in the reflections. That's awesome. Numbers are reversed. Switching. Good. Learning some methods for finding it. Awesome. Great. So far, these reflections are looking good. Make sure you put yours in there. Good. Oh, good. Learning how to solve using algebra. That's always good. We got the reflection across the line y equals x. Great. And then the original function is mirrored. Awesome. And then feel free to put any questions if there's any that you're leaving here and you still have some questions about. It's also good to do as a checkout. All right, everyone. Thank you for sharing your process and your reflection. So again, I'm going to create right now the assignment to please submit the notes only on inverse functions. You're going to take pictures of it. And as a reminder, your asynchronous number 6 is due tonight at 11:59. Yeah, the class was quick. All right, y'all. Have a great lunchtime. Yeah. Bye, everybody. I'm going to put in an assignment right now.
Bye.
So, bye.